So today we discuss another type of the first order differential equation, which is called exact equation. Okay, but before we discuss the method of solution, so let's see. Okay, we want to know whether your equation is exact or non-exact. Okay, so let's see how to classify these types of the differential equation. Okay, so let's see the definition first. Okay. The exact equation is a first order differential equation of this form. Okay, and this equation is called exact equation if and only if the partial derivative of the function m here with respect to y must be equal to the partial derivative of the n function from this equation with respect to x. So if you get the same answer for these two, then this equation is called an exact equation. Okay, so meaning to say that firstly that your first order differential equation must be written in this form. Okay, this is the standard form of the equation, and this equation containing the coefficient of the dx, which is this one m, and the coefficient for dy, which is the n function. Okay, so after you identify these two functions, then you try to differentiate this function, the m here, with respect to y, partially with respect to y. Okay, and this n differentiate partially with respect to x. Okay, and if you get the same answer, then this equation is called an exact equation. So this is the test for exactness. This is a test that you can use to check or to classify whether this equation is an exact equation or not. If you didn't get the same answer, then your conclusion will be not an exact equation. Okay, so let's see some example. So you have here determine the exactness of the following differential equation. Okay, this is how to classify your exact equation. So let's see, you are given this differential equation in terms of dx dy. Okay, so now you look at this equation. This equation is already in standard form. Okay, as given by the previous slide. This is the m function times dx plus the n function times dy equal to 0. Okay, so since that this is already in standard form, then we can apply the test for exactness to know whether this is exact or non-exact. Okay, so let's see here. Okay, now you have this equation. If you look at the standard form of the equation, so this one is actually match this standard form. So means that I can say that this 3x square y is the m function, and this x cubed minus 1 is the n function. Okay, so therefore we use the test for exactness. So we try to differentiate the m function here with respect to y. Since that this is the function in two variables, so we have to use the partial derivative, differentiate this with respect to y only. So meaning to say that the other terms, 3x squared here is considered as a constant. So so you just factor out the 3x squared, you just differentiate the y only. Okay, so if you differentiate the y with respect to y, you get 1. So that's why you can hear here the del m over del y is equal to 3x squared. Okay, so this one involve partial derivative. Okay, now for the next one is the n function. Okay, differentiate partially with respect to x. Okay, so this one should be no problem because this is a function in one variable. So you just differentiate x cubed, you get 3x squared. Differentiate negative 1, you get 0. Then you can see that the partial derivative del m over del y, the value here, the result here, 3x squared. This one also 3x squared. So these two are equal. So therefore, this equation is an exact equation. Okay, the next example, also same question, determine the exactness of the following differential equation. So now you are given the equation x squared y squared plus 1 dy plus xy cubed dx equal to 0. Okay, so you can see from this equation also given in standard form of the equation of the exact equation. Okay, so this one is actually, if you try to compare this with the standard form is like this. Okay, so you have m dx plus n dy equal to 0. So you compare with this. So if you compare here, okay, since that the first term here is the coefficient of dy, so means that this is not m, this is n. Okay, the n function according to this standard form, and this xy cube is the m function. Okay, So be careful. Sometimes we can write the terms in terms of dy first, okay, and then after that dx. So you have to make sure you know which one is your m function, which one is the n function. Okay. So after you identify the m, which one is the m function, which one is the n function, so we can use the test for exactness. So for this m, okay, we differentiate this term with respect to y only. Okay, so meaning to say that the x no need to differentiate, you just consider as a constant, you just factor out the x. So you just need to differentiate the y cube. So y cube differentiate, get 3y square. So that's why here you get 3xy y square. So this is the del m over del y. Okay, and then for the n function here, okay, so this differentiate this n function with respect to x. Okay, so now only differentiate the x square, you get 2x, then after that multiply by y square, so you get 2xy square, and differentiate 1, you get 0. So this one, okay, the del n over del x, you'll get the answer is 2xy square. Okay, then you compare this with the del m over del y, then you can see that these two are different answer. So therefore this equation is non-exact. Okay, the next example, how to classify the exact equation. So let's see you are given this differential equation, y cube minus x cube dy over dx equal to 3x square y plus 1. Okay, so we want to check whether this is exact equation or non-exact equation. Okay, so since that the equation here is not given in standard form, m dx plus n dy equal to 0. So you can see here, this equation is not in standard form because the standard form should be like this. Okay, the m dx plus n dy equal to 0. So we need to modify this equation. Okay, so you have to do the algebraic manipulation, means that okay, this one must be in terms of dy dx. Okay, so all multiply by dx first. Okay, so you can see from here, multiply all by dx, so you get this equation. Then still not this is still not in standard form, okay, because the standard form must be one side here 0. Okay, so you have two options. Either you want to move this part to the left hand side, or you want to move this to the right hand side, so that one side will be equal to 0. Okay, so here I move this part, okay, to the right hand side, so I get here 3x square y plus 1 dx, and then minus, okay, minus bracket, okay, y cube minus x cube dy equal to 0. So since that I get this is already equal to 0, then it's actually match the standard form. So based on this formula, my m function will be this, and my n function, since that there is a negative here, okay, the original formula is a plus, means that if you have negative, you have to include the negative also. So that my n will be negative. You can open the bracket, you can multiply this, okay, all this by the negative, or you can just take negative minus the negative okay, y cube minus x cube. This is your n. Okay, now after you get the m function and the n function, then we can check for the exactness. Okay, so now this m function, okay, we want to differentiate this with respect to y, okay, the del m over del y. So now we have 3x squared, so this one no need to differentiate, you just differentiate y only, so you get 3x squared times 1, okay, and then differentiate 1, you get 0, so this one will be del m over del y will be 3x squared. And for the n function, okay, the n function is the whole thing here, including the negative. Okay, so let's see, you open the bracket, become negative y cube, okay, plus x cube, which is this one. Okay, so this one, okay, differentiate this n with respect to x. So differentiate the negative y cube will be 0 because we consider this as a constant. Okay, so you differentiate constant, okay, will be 0. Okay, because this one doesn't involve any x here. Okay, only y. Okay, and this x cube, okay, differentiate with respect to x, you get 3x squared. Okay, so you get same answer for both okay, partial derivative here. So therefore the equation is an exact equation. Okay, so if you are given any equation which is not in standard form, make sure you write this equation, okay, in this form first. Okay, identify your m and the n. Then after that you can apply the test for exactness. Okay, the simplest way how to remember this test, the formula for the test for exactness, is that you look at the differential, the dx dy. if you have the differential dx here, okay, means that this coefficient you have to differentiate with respect to the opposite variable, which is y, okay. And here, this is the differential dy, okay. So this, any function here, you have to differentiate with respect to the opposite variable of this, which is the x, okay. So, okay, that one will represent the test for the exactness. So it doesn't matter if you want to indicate m or n, it doesn't matter. Okay, just like, okay, whenever you have given a standard form like this, okay, this coefficient you have to differentiate with respect to the opposite variable of this, okay. And this one also you have to differentiate with this function with respect to the opposite variable of this one. So that's how to know your test for exactness, okay. This one, the m and n is just for formulation. We just indicate m and n because it's easier to show you the formula, okay. But exactly, you just refer to the dx and dy, okay. Okay, so this is another exercise on how to classify the differential equation, the exact differential equation. So dy over dx equal to this. So this one also the example of the differential equation which is not given in standard form. Okay, so what you have to do to answer this question is to write this equation first in standard form, which is in this form. Okay. So first, okay, this one dy over dx equal to this. So you have to multiply all by dx so that you get this equation. And then one of these you have to move to one side first. Okay. So in this case, I move this one because I want to follow this. Okay, this equation, this standard form. So okay, I want to write the dx first. So I move this part to the other side. So you get this. Then from here you identify your m. Okay, and identify the n function. And then you apply the test for exactness. The m differentiate with respect to y. Okay. So here the 4x is assumed as a constant. So you just differentiate the e to the power of y only. So you still get the same function, e to the power of y. And this part, since that is the negative here, so you have to include the negative for the function n. So all these differentiate with respect to x. Okay, so if you open the bracket, it become -1 plus this. Okay, so now I differentiate the x only. So this one will be a 4x times e to the power of y. Okay, so you get 4x times e to the power of y. Okay, so you get the same answer for these two partial derivative. Then this equation, okay, is an exact equation. Okay. So now we will discuss the method of solution for the exact equation. Okay. First of all, okay, when you are given the equation in this standard form, okay, first you need to double check whether this equation is an exact equation or not, okay, because if this equation is not exact, we cannot use this method of solution, okay. So once it's exact, then according to the method of solution, okay, you will get a function f, okay, in terms of x and y equal to the constant c, okay, for which that when you differentiate this function partially with respect to x, the answer is equal to m function. Okay, the m function actually exactly same as the given in the equation, the differential equation. Okay, and when you differentiate this function with respect to y partially, then the answer will be equal to n. Okay. So once they become exact, you will get this kind of function f or fxy equal to c, where these two are satisfied. Okay, but if this one is not exact, then we cannot use these two equation. Okay, it's not satisfied these two equation, so therefore you have to use other method to solve the non-exact equation. Okay, so therefore this function fxy equal to c is called an implicit solution for the exact equation. Okay, and now the challenge is to find what is the function f of xy. Okay, because to get this, once you get this function f, then you just put the whatever resulting function you obtain, okay, after you solving, then just put here equal to c, then that one will be the final answer, the general solution for this exact equation. Okay, so let's see the proving first. Okay, how we get these two kind of these two kind equation here. Okay, So let's see, I will show you the proving. Okay, let's see, this is the function f x y equal to c. So let's see, this function k is a solution for the given exact equation. So we know that from the chapter 1, if this function is a solution, means that if I substitute this function into the given exact equation, this function will satisfy this equation equal to 0. Okay, so now what you have to do, this one is actually the implicit function. So implicit function we cannot substitute directly into the equation, so you have to differentiate this function with respect to x and y. Okay, since that this one is a function in two variables. Okay, so when we differentiate this function, you will get like this. Okay, you have then you differentiate the f partially with respect to x first, then after that you differentiate x. Okay, and here you differentiate f partially with respect to y, then after that you differentiate y. So this is the way how to find the derivative for any function in terms of two variables. So this one, here this is the derivative of this. Then the c differentiate equal to 0. Then if you compare this equation with the standard form, these two are actually exactly same but different form. You can see that this is dx, this is dx, this is dy and dy. So meaning to say that if this function satisfy this equation, definitely the del f over del x must be equal to this, the m function, and del f over del y must be equal to the n. So that's why you get these two equation. Okay, so therefore this fxy equal to c will satisfy the differential equation. Okay, so this is the proving why we get how you get these two formula in order to get the function f. Okay, so let's see the example how to find the solution for the exact equation. Okay, so this is the first example. Solve the following exact differential equation. Okay, so you are given 6xy dx plus 3x squared plus 2y dy equal to 0. Okay, and you look at this equation. This equation is already in standard form, m dx plus n dy equal to 0. So no need to modify this equation. Okay, and one thing is that the question asks you to solve the following exact equation, meaning to say that we no need to do any testing, because this is already exact. This is confirmed exact. Okay, so in this case, no need to do any testing for exactness. Okay, we just need to immediately solve the equation by using the technique that we discussed just now. Okay, okay, now this is the equation. We start with the equation. So for the I just put here the notation. This is the m according to the standard form of the exact equation, m dx plus n dy equal to 0. So since that this is already exact, so we can skip the test for exactness. Okay, so therefore since that this one, we have to find a function f x y equal to c, for which that the m function here is equal to del f over del x, and the n function here is equal to del f over del y. This is according to what we proved just now, to get the function f x y. Okay, so this one here, based on this equation, 6xy is actually del f over del x. And then the 3x squared plus 2y is the del f over del y. So you need to define these two first. Okay, so this is equation number 1, equation number 2. And once you get these two, then the target is to get the function f. So this is actually the del f over del x. We can find the f from here by doing the integration of f with respect to x. You have to integrate both sides here with respect to x to get the f. And here also we can find the function f also by integrate both sides with respect to y. So in order to get the f, we have to integrate these two equation with respect to the given variable. So let's see here. How to do that? You integrate equation number 1 with respect to x, and integrate equation number 2 with respect to y. And after you get the function f for each equation, you have to merge the two resulting expression to obtain the desired function f x y. So how to do that? So you integrate the equation 1 with respect to x. This is the first equation, del f over del x equal to 6xy. So we find the f by integrate the 6xy with respect to x according to this, yeah, okay. And then from here, since that we want to integrate x, means that the 6 and y here we can take out from the, we can factor out from the integral 6y, because this one is considered as a constant. So you just factor out. So we just need to integrate x only with respect to x, okay. And by doing integration, this is x squared over 2 after integration, x squared over 2, then the this one is 6, and then over 2, 6 over 2 you get 3, then the answer will be 3x squared y. This is after you do the integration and then multiply back with the 6y. Okay, so you get 3x squared y. And okay, remember every time you integrate, okay, you will have the constant of integration. Okay, but here since that we integrate this with partially with respect to the variable x, so meaning to say that the constant of integration will be a function in y, because just now, okay, a function in y we consider as a constant. So after you do the integration, the constant of integration will be a function in y, because this one become a constant. Okay, okay, so this is from the equation 1. Okay, and equation 2, integrate with respect to y, del f over del y equal to this. So you get your f, integrate the whole thing with respect to y. Okay, then here, since that this is the summation of two terms here, so we can split into two integrals. Okay, 3x squared, the integrate with respect to y. This one integrate with respect to y. I think this one should be no problem. Okay, because this one is actually when you integrate, get y squared over 2. Okay, sorry, y square. Okay, y square only. Okay, and this part, okay, since that okay, this one, even though that there is no y term here, okay, actually this 3x square is actually a constant. We can factor out the constant outside the integral, so the remaining term here will be 1. Okay, so you integrate 1, actually you integrate 1 with respect to y, then you will get 3x square y, and this part is actually y square. And the constant of integration after you integrate this with respect to y will be a function in x. So you cannot put plus c here lah, because this is a function in two variables. So this one will be a function in x. Okay? Here the constant of integration is a function in y. Okay, so you get the function f from the first equation and the second equation, and you can see that this one you get f, this one also you get f. So actually these two are equal. Okay, whatever you get here are equal, is equal to this one, the second, from the second equation. So how to merge these two so that you get the final answer for fxy? Okay, so this is the one that we did before. You compare both result. Okay, these two are equal. Okay, now if you want to take your answer for fx from here, yes, can. But the problem is that you don't know what is the function gy. Okay, and same here, if you want to find your function f from here, yes, can. But the problem is that you don't know what's the function hx. Okay, so we compare these two results. Okay, so therefore from this comparison we can obtain the function gy and the function hx. Okay, since that these two are equal, means that okay, how to get the gy is from here, from this equation. Okay, how to get the hx is from the first equation, because these two are equal. Okay, so the gy here, okay, is a function in y alone. So you find what is the function in y alone in the second result here, which is actually the y square. Okay, so the gy equal to y square. And the hx is the function in x alone. So you see from here, is there any function in x alone? This one, x and y. So there is no function in x alone. So means that your hx equal to 0. Okay, so you know already your function of gy and the function of hx by comparing these two results. Okay, then it is up to you, the final answer for f. You can choose the first one or you can choose the second one. Okay, so here let's see, I choose the first one. So therefore my function f of xy is equal to 3x squared plus the gy here is the y squared. Okay, you can also take from here 3x squared y plus y squared plus 0. You still get the same answer. So this is your fxy. Okay, so therefore the general solution for the exact equation, okay, is given by 3x squared y plus y squared equal to C. So just now this one is a function f. So the implicit solution for the exact equation just equal to C. So this is the final answer for the exact equation.